All right, here we go, getting into chapter 3 of pre-algebra. In chapter 3 is getting into equations and solving. And, I hate to put importance on a chapter, but if there's a chapter that you build upon and you come back and see in every other math class that you'll take, it's dealing with equations and solving. Now, we're going to look at the basics of that in chapter 3. But you'll see this again a ton in algebra, and you'll build upon what you learn here, and you'll do more difficult problems in solving. You'll connect it to graphs, which we will also do later on this year as well. But chapter 3 is very, very important to understand for success in all other classes. Okay, and at first it may be difficult. At first, you may have struggles, but do your best to stick with it and persevere and try to gain a good understanding of what we're doing, and not just the steps to which we do things, but the why and the understanding of how that works. Section 3.1, we're going to start with the distributive property. This is a property, like I said, that'll be used in solving. It's used in simplifying. That we'll see that today. Our target is to use a distributive property to write equivalent numerical and algebraic expressions with heavy emphasis on the algebraic part, the ones that contain variables. Our key terms are equivalent expressions. Okay, those are expressions with the same value. They may look different in form, but they are the exact same value. And the distributive property uses multiplication to each term in a set of parentheses, and then it adds the resulting terms together. If it's just numerical, you're able to combine those because they'll be like terms. If it's algebraic, you'll have one variable term and one number term, and you'll just leave it as that. And we'll look at examples of what that actually means. All right, so here's using the distributive property with numerical expressions. Okay, and I'm going to first talk about how it's not really necessary to use the distributive property when it's numerical, because we learned with the order of operations that I can do parentheses first, then exponents, then multiplication or division, and then addition or subtraction. So I'm going to first show you what it looks like using the order of operations. I can first combine these parentheses, right? 6 plus 4, and I get 10. And then I have this 2 times 10, which would give me 20. Okay, so that would be using the order of operations to solve. The distributive property allows us to take the number on the outside of the parenthesis and multiply each term inside the parentheses. So another way to do that, right, and we'll talk about equivalent expressions, I could take 2 times 6 and get 12, and 2 times a positive 4 to get a positive 8, right? So this expression and this expression are equivalent, and both of them are equivalent to 20. So you can see that either way will arrive at the same solution. Okay, I'd like you to pause the video here and try example 2, 3, and 4. Okay, I'd like you to use the distributive property since that's what we're practicing here. All right, and if you want to check it with order of operations, you may do so. So pause here and try those 3. All right, so let's see how you did. In number 2, using the distributive property, it'd be the same as 15 plus 3, which would equal 18. Or if you added the inside first, you get 6 times 3, which is also 18. All right, you can see the work here for number 3, or example 3 and example 4. I don't know why this little 5 times 8, right, which gave us 40 there. All right, let's look at that with a word problem here. It says a one-day pass to an amusement park costs $50, plus the round trip bus ticket costs $5. It says write two equivalent expressions to find the total cost of a one-day pass and a bus ticket for 10 students. So I could take the 10 students times the 50 plus the 5, right? So meaning I could add the 50 and the 5 to find the total it costs for one person and then multiply it by 10. Or I could take 10 times 50 because there's 10 students who are going to get an amusement park pass plus the 10 students times the $5 bus fee. All right, those are equivalent expressions. And if I solved either one, right, this would be 10 times 55, which should equal $550 total for all 10, right? And you'd see here if we did this individually, we have 500 plus 50, right? 10 times 50 is 500, 10 times 5 is 50. And again, we get 550 for the total cost, right? So we could multiply each one individually by the 10, add them together, or we could do adding of the 5 and 50 for the total cost per person of $55 and then multiply that by the 10. All right, using the distributive property on algebraic expressions. This is where you have to use the distributive property because I can't combine a variable plus a number. All right, so in order to simplify this or write an equivalent expression, I would take this outside number and I'd multiply. 2 times x would be 2x. 2 times a positive 5 would be a positive 10. So that would be 2x plus 10. Nothing else I could do with that. I just multiply each term on the inside. Now, looking down at number 4, notice that the number comes afterwards. It's the same thing. It's a multiplication problem. So I can take 7 times the y and get 7y. And I can take 7 times positive 3 and get a positive 21. So my answer would be 7y plus 21. Take a minute, pause the video here, and see if you can answer the other 4 examples. All right, let's see how you did. All right, and you can see that I wrote these in what's called standard form. And that's typically where you have your variable term first and then your number term second. Okay, there are other ways that you could write this, right? We talked about our commutative property with addition. I would love for you to write it that way with the variable first and the number second, but it's not wrong if you were to write this as a 10 plus 2x in number 1. Number 4, I could have 21 plus 7y. All right, I do have to be careful that I make sure that they do have the correct signs when I'm writing them. So if we look at number 2, right, 5 times 3x would be 15x. 5 times negative 1 would be a negative 5. Now, if I were to rewrite this, I could write it as negative 5 and a positive 15x. That's another way to write that. Number 3, we have 4a and 16. Okay, in a common mistake, we got to make sure we're multiplying here. A lot of times I see us multiply the first term and get 4a, and then the second term and get 8 because we add those values, right? Remember, we got to multiply both terms by that number on the outside. So here I could have written that as 16 plus 4a. Also want to talk about number 2. You could have had that as 15x plus a negative 5. That's also saying the same thing, right? Plus a negative is the same as a minus, right? Plus -5 is the same as -5. So there's another way to write that. Here, got to be careful because I have the -5 times the -4. That should give me positive 20. And I have -5 times z is -5z. If I were to rewrite this, I could have had 20 minus 5z. Sorry, let me erase that. That was a bad one there. Minus 5z, or I could have had that as 20 plus, whoa, sorry, getting crazy here. Let me try that again. Oh, still. It's tough being a lefty writing on these boards here. Oh, still on the eraser. So there's 20 plus -5z. And here we could have had 32 minus 16x, or 32 plus -16x. All right. So we can also use or extend this to mental math, right? These are basic skills, right, in solving. But I could change this problem to some easier problems. For example, 14 is really 10 plus 4, right? So I could do 7 times 14, and you could do that the old way. Or I could do 10 plus 4 is 14, and I know that 7 times 10 is 70, and 7 times 4 is 28, right? And then in my head, I could say, okay, 70 plus 28, that's 98, right? So 7 times 14 is 98, right? Or here I could say that 23 is really 20 plus 3. So 8 times 20 would be 160, and 8 times 3 would be 24. So adding those, that would give me 184. So 8 times 23 will give me 184. Right here, I could say 16, so 11. I'm going to separate that into 10 plus 1. Right, multiplying by tens, right, 10 or 20 or 30 or hundreds, it makes it a little bit easier because I know that 16 times 10 is 160, and 16 times 1 is 16. So if I add those real quick, that would give me 176. See if you can extend that and mentally solve 4, 5, and 6, right? And starting off with here, probably the best way to would be 100 plus 2 would give you 102. So pause the video here and see if you can solve those mentally. All right, let's check them out here, see how you did, right? And the times by 11 is kind of a cool pattern that emerges, and this is for nothing more than just a fun fact. I'm going to show you a few examples of multiplying by 11 and the pattern that gets created there. All right, take a minute, pause the video, and write these problems down. So we're going to do 11 times 15,361. And then we're going to do 11 times 342,961. So pause real quick and write those down. All right, like I said, this is just a trick when multiplying by 11. All right, so you can get a calculator and check this out, but this answer is going to be 1, right, from the first one, and then from here, so the first number stays the same, and then I'm just going to multiply, or excuse me, I'm going to add the next two together, so that would give me 6, and then 5 and 3 is 8, 3 and 6 is 9, 6 and 1 is 7, and then the last number stays the same. So it would be 168,971. So that's just a quick way to multiply by 11. It does get a little bit more difficult when you have numbers that add higher than 10. So I'll show you an example here. So first number stays the same, right? 3 and 4 is 7. 4 and 2 is 6. 2 and 9 is 11. So I'm going to write that here, and I have to add 1 to that. And then 9 and 6 is 15. So I'm going to write the 5, and then I have to add 1 to that column. 6 and 1 is 7, and then the last number stays the same. So here is 3, 7, 7, 2, 5, 7, 1. All right. Take a minute and pause and see if you can use that method to multiply 11 times 241,721. All right, remember, first one stays the same, so we would have 2, 6, 5, 8, 9, 3, 1. Right, first one, then we add these two as 6, 5, 8, 9, 3. Last number stays the same as a 1. All right, and then one more just for good measure. We have 1, 8, 11, right? So I have to add 1 there. 7, 11. So then I add 1 here. 9, 5, 4. Right? So again, useless trivia there, but that allows you to maybe show that to somebody and impress them with how fast you can multiply by 11. All right. Anyways, on to the homework. So your assignment starts on page 100 for section 3.1. Going to be working on numbers 4 through 9, 11 to 23, 26 through 48 even, and number 65. All right. Do that on a separate sheet of paper. Email me with any questions, and I hope you have a great day and an even better weekend. All right. Take care.